Audible?
Yes, sir.
The screen share is okay, visible.
Yes, sir.
Last class we were discussing about this problem. Is we have three spheres here, and sphere A and sphere B are having a weight of 4 kilonewton, and sphere C having a weight of 6 kilonewton, and the corresponding diameters of the DA and DB and DCs are given. And this is the figure. So first what you have to do is you have to find out this angle. So now they join the centers of sphere A and sphere C. And since the diameters have been given, so DA is 500 millimeters. So the radius will be 250 and this is 600 millimeters. And obviously the radius is 400. So the distance AC is 600 and AD, so you drop a vertical from point C, so which will cut the horizontal line AB at point D, and AD is 300 millimeters. That is this total is 600. So if you take out the diameter, correct? So this is 600. So half of which is 300. So thereby you'll get this angle theta. So now we can calculate the angle theta. It works out to be 62.51. Now, since you have to start with the sphere C, because here you have two unknowns. Now, first we have to identify the contact points where the sphere makes the contact with the sides of the container and as well as between the spheres. Now here sphere A is making a contact at this point and at this point, and in between these two spheres you have a contact point K, and similarly sphere B, it is making a contact right over here and at this point, and also between the sphere B and sphere C, you have a contact point that is L. So now you have to find these reactions, contact reactions, that is RP, RO, RK, RL, RN, and RN. So now already we have found this angle. So now let us draw the free body diagram of the sphere C. So if you draw the free body diagram of the sphere C, the weight of this sphere C acts vertically downwards, it is 6 kilonewton, and you have a reaction from sphere C to sphere A. So you can call it as RK, and similarly you have a reaction force from sphere C to sphere B through this contact point. So you can call it as RL. So these two are the reaction forces. So here, with respect to sphere C, you have only two unknowns. That means three forces are acting at a point, so you can comfortably use the Lami's theorem. Now let us go through the free body diagram of sphere C. The weight of this sphere acts vertically downwards, and you have a reaction force RK and RL. So these angles already you have found, 62.51. Now the angle between the force RK and RL is 54 something. And this angle is 90 plus 62.51. This angle is 90 plus 62.51. Now you can apply the Lami's theorem, and thereby you'll get the values of RK and RL as 3.382 kilonewton. So now once you find RK and RL, so we can start with the sphere A. So if you draw the free body diagram of sphere A, the weight of the sphere acts vertically downwards, that is 4 kilonewton, and you have a reaction RP acting like this, and which makes an angle 15 degree with respect to horizontal axis and 75 degree with respect to the vertical axis. So you have a reaction RP, and from the bottom you have a reaction RO, and you have a reaction from sphere A to sphere C, that is RK. RK already you have found, and this angle you know. So now let us go through the free body diagram of sphere A. Just let us check. Now you can see here RO and RP. RP is acting like this. So this angle is 15 degree. So this makes an angle 75 degree with respect to vertical axis. And RK is acting like this. So this angle is 62.51. Already we have found. Now here, since you have four forces acting at this point, you cannot apply the Lami's theorem. So you have to go apply the equilibrium method. So let us first put sigma f of y is equal to 0, sigma f of y is equal to 0 or x is equal to 0. So now you can see RP cos 15 minus Rk cos 62.51 is equal to 0. So thereby you get the reaction component, that is Rp. So once you get Rp, then sigma f of y is 0, that is Ro minus 4 kilonewton, Ro minus 4 minus Rk sine 62.51. So thereby you get the value of Ro. Now let us check. Sigma f of y is 0, Ro happens to be 6.582 Newton. So similarly, we have to find the reaction with respect to sphere B. So we have to find Rn, and RL already you have calculated. So now let us look at the free body diagram of the sphere B. So now you have Rn, and Rn is acting like this. So this angle is 45 degree. So because it is making an angle 65 degree with respect to the vertical axis, so if the reaction component is like this, so this angle will be 25. Now this angle is 25. Now apply the condition sigma f of x is equal to 0. So Rm minus Rm cos 25 or minus Rm sin 65, whichever may be. So I will be taking 25 degree. So Rm minus Rm cos 25 degree plus RL cos 62.51. So already you have found this RL. So sigma f of x is 0. RL cos 25 minus Rm sin 65. It is Rm sin 25 is equal to 0. Thereby you get the value of Rm as 1.722 kilonewton. Similarly, apply the next condition, sigma f of y is 0. So Rn minus 4 plus Rm sin 25 minus RL sin 62.5. Right? Sigma f of y is 0. Rn minus 4 plus Rm sin 25 or Rm cos 65 minus RL sin 62.51. So thereby you get the value of Rm. So now let us check. Rm minus 4 minus RL sin 62.51 plus, so plus Rm cos 65 or Rm sin 25. So thereby you get the value of Rm. So these are the contact reactions with respect to three spheres, that is Rp, Ro, Rk, RL, Rm and Rn. So any doubts with this problem, anyone? I think we can move on to the next one. Is it clear? Anybody is having any clarification or doubt? Hello? Shall I move on to the next one? Now again, so you have similar problem here. So you have three spheres, that is A, B, and C, and the corresponding weights are given. That is 1 kilonewton, 1 kilonewton, 1 kilonewton. So here you have to find now we have to find the contact reactions. So determine the reactions at the surface of contact and tension in the string AB. So I think AB is a, so this is a string connected with these two spheres. It is almost similar to the previous one. Here in the case of previous one, you have the sloping sides on either side. So here you have to find the reactions. That is, this one is RA, right? Or you can call it as ABC. You can call it as 0.1. So this is 0.2, 0.3, 0.4. So you can go through this problem. It's almost similar to the previous one. So now let us solve some of the exercise problems. Now here, a ball of weight 120 Newton rests in a right angle groove as shown in figure. The sides of the groove are inclined at an angle 30 degree and 60 degree to the horizontal. If the entire surface is smooth, determine the reactions RA and RC at the points of contact. So it is a very simple problem. Now here you have a sphere of weight 120 Newton. It makes a contact with the sides of the V-shaped group, that is right angle group at point C and point A. So you have to find the contact reactions, that is RC and RA. Now if you draw the free body diagram of this given figure, so the weight of the sphere acts vertically downwards, that is 120 Newton acts vertically downwards, and you have a reaction RC, which makes an angle 60 degree with respect to horizontal axis, and similarly you have a reaction force RA like this, and this angle is 30 degree. So here RC component is making an angle 60 degree with respect to horizontal, whereas RA component is making an angle 30 degree with respect to the horizontal axis. Now let us draw the free body diagram. So you please take a piece of paper and a pen and draw the free body diagram. That is, the weight of the sphere acts vertically downwards 120, and you have a reaction RC which makes an angle 60 degree with respect to horizontal, and similarly you have a reaction RA. So you complete this triangle. So better you complete this triangle. So this angle will be 90. Obviously this is 30 and this is 60. Now apply the equilibrium condition on this sphere. Sigma f of x is equal to 0. Sigma f of x is equal to 0. That means here you have the component RC. So if you direct this RC component, it is acting in the first quadrant. And if you direct this RA component, reaction component, it is acting in the second quadrant. So sigma f of x is equal to 0. RC cos 60, minus RA cos 30. RC cos 60 minus RA cos 30 is equal to 0. Or RC is equal to RA cos 30 divided by cos 60. What is the answer? Tell me. You'll get RC in terms of RA. So anyone? So write down the equation. Sigma f of x is equal to 0. RC cos 60 minus RA cos 30 is equal to 0. Or RC is equal to RA 30 divided by cos 60. So I will get RC in terms of RA. How much it is? Anyone has done it? So we'll get the value of RC in terms of RA. It's cos 30 by cos 60. How much it is? Anyone? How much it is? Hello? So RC is 1.37 times RA, correct?
Yes, sir.
RC is equal to how much time you require to just tell the answer? So RC is equal to 73 times RA. Now you apply sigma f of y is equal to 0. Sigma f of y is equal to 0. So RC sine 60 plus RA sine 30, RC sine 60 plus RA sine 30 minus 120 is equal to 0. You call this equation as 2. So you can substitute RC in terms of RA. That is, RC is equal to 1.73 times RA. So thereby you will get the values of RA and RB. So once you get the value of, because you are substituting RC in terms of RA, you will get the value of RA. So once you get the value of RA, RC is equal to 1.73 times RA. So thereby you will get the values of RC and RA. Please tell me the answer and check here whether the answers are correct. So here, according to this, RA is 60 Newton and RC is 103.942. Are the answers okay? Bharati Hegde, yes, sir.
Six.
Are the answers are correct? RA 60 Newton and RC is 103.942.
Yes, sir. RA is equal to 60.06 Newton. RC is equal to 103.90 Newton.
Very nice. Okay. So again, we shall discuss some more problems. Now again here you have two spheres. So two spheres of weight 1000 Newton and of radius 25 centimeter rest in a horizontal channel of width 90 millimeters. So it is a box. It's a box having a width of 90 centimeters as shown in figure. Find the reactions on the points of contact A, B, C, and D. So now here you have two spheres, and the weight of these spheres are same, is 1000 Newton, and the diameters are 50 centimeters each, and it is being placed in a square box of width 90 centimeters. Now first we have to find out the contact points. So this is the point at which the sphere 1 makes the contact with the one of the sides and at the bottom. So these are the points of contact A, B, so C and D. So we are supposed to calculate the reactions RA, RB, RC and RD. Now let us draw the free body diagram of sphere 1. Now here we need the angle, correct? One of the angle we need because RA is horizontal, RB is vertical, RC is vertical, and RD is because if you join the center of these two spheres, this is the center of the sphere 1 and center of the sphere 2. Now suppose if I take this as point O1 and if I consider this as O2, so join points O1 and O2. Join points O1 and O2. So this is 25 centimeters and this is also 25 centimeters. So O1, O2 is 50 centimeters, 50 centimeters. Now from point O2, so you drop a vertical, and from this point you draw a horizontal. Now this is 25 centimeters and this is 25 centimeters, correct? So now you join point O1, O2 and drop a vertical and call this point as O3. So call this point as O3. So you will get a triangle like this. Okay. So O1, O2 is 50 because the radius of each sphere is 25 plus 25, 50. And O1, O3. O1, O3 is how much? This is 25 and this is 25. So totally 50. If you take over 50 from 90, so O1, O3 is 40. So thereby you get the angle theta. So you have to construct a triangle like this, O1, O2, O3. So O1, O2 is, it is 50 centimeters and O1, O3 is 40 centimeters. So cos theta, you want this angle, correct? Because this reaction will be inclined, which makes an angle theta with respect to the horizontal. So cos theta is equal to O13 divided by O1, O2. So O13 is 40 and O1, O2 is 50. Correct? Cos theta adjacent by hypotenuse 40 divided by 50. Theta is equal to cos inverse 40 divided by 50. What is the angle? Please tell me. Anyone? Theta is cos inverse 40 divided by 50. How much it is?
36.86.
Okay, 36.86, correct? Hello? How much? Theta, the value of theta? Somebody said no. May I know who is?
Yes, sir.
It is
86.
36.86. Now, so first you consider this sphere. So try to draw the free body diagram. So you write a circle here. At the center, you draw the axis X and Y. So you draw a circle. At the center, you draw the axis which passes through the center of the sphere. Now you have a reaction like this, RA acting in the positive direction, RB acting in the upward direction, RB from the bottom of the sphere acting vertically upwards, and you will have a reaction RD like this, and this angle you have found 36.86, correct? And the weight of the sphere is 1000 Newton, acting vertically downwards. Now here, if you take this sphere 1, you have 1, 2, 3, 4 forces are acting at this point. So then, because here you have 3 unknowns, RA, RB, and RD. So now let us take the sphere 2. Now, if you draw the free body diagram, so pass the reference axis like this, which passes through the center, and you have a reaction RC like this, RC, the weight of the sphere acting vertically downwards, and you will have a reaction RD like this, which makes an angle 36.86. Now, you draw the free body diagram of spheres 2 and find out the reactions RC and RD. So now here you have 3 forces. One is RC acting in the horizontal direction towards the negative axis, and RD, it is acting like this. It acts in the first quadrant, which makes an angle 36.86 with respect to horizontal, and the weight of the sphere acting vertically downwards. So you can either apply Lami's theorem or you can apply the equilibrium method. Now let us apply the equilibrium method for sphere 2. Sigma f of x is equal to 0. Sigma f of x is equal to 0. That is minus RC plus RD cos 36.86 is equal to 0. Correct? Sigma f of x is equal to 0. That is minus RC plus RD cos 36.86 is equal to 0. RC is equal to RD cos 36.86. Next, sigma f of y is equal to 0. Sigma f of y is equal to 0. So thereby, that is RD sin 60 minus 1000 is equal to 0. 1000 is equal to 0. Or RD is equal to 1000 divided by sin 60. So check the answer. 1000 divided by 0.86. How much? Thousand divided by 0.59. Correct. We get it as 1694 something. Just check it. What is the answer? Anyone?
1694.91.
1694.91. So here there is some printing mistake. Okay. Whatever the answer you get, you right. RD happens to be 1694.91 Newton. Now, in the first equation, sigma f of x is equal to 0. That is RC is equal to RD cos 36.86. Correct? RC is equal to RD cos 36.86. So RD value you got 1694 point something. That multiplied by cos 36.86. So just check the answer, RC. Whether the answer is correct.
135.592.
Okay, 1335, no? Correct?
Yes, sir.
135. Yes, sir.
Not 135, it is 1033, I think.
1355.92.
Okay. Now you take up the sphere 1 and draw the free body diagram. So RA, RB, the weight of the sphere at vertically downwards, and already you know the RD, that is the reaction from at this point, that is 1691. Now apply the condition sigma f of x is equal to 0. Sigma f of x is equal to 0. That is RA minus RA minus RD cos 36.86 is equal to 0. RA minus RD cos 36.86 equal to 0, or RA is equal to RD into cos 36.86. So check whether the RA is same. Sigma f of x is equal to 0. That is RA minus RD cos 36.86 equal to 0, or RA is equal to R cos 36.86 times RD. How much it is? Same. So, these two spheres are identical, no? Hence, RA will be equal to RC. Is it correct? The answer 1355 something. Same answers.
Yes, sir.
And once you find RA, then sigma f of y is equal to 0. That is RB minus 1000, minus RD sine 36.86 is equal to 0. Thereby, you get the value of RB. Please check it. Answers correct idea, Nodi, RB. How much you got? Is it okay? Hello?
2016.71.
Okay. Oh, nothing to worry, because here some printing mistake is there. Whatever the answer, the procedure must be correct. That's all. Okay. So that completes the under equilibrium of planar force system. So this completes the concurrent force system. So you have many exercise problems. You can go through these problems and the concept remains there. Only thing is you have to draw the free body diagrams properly. Then apply the condition sigma f of x and sigma f of y is equal to 0. So if there are three forces acting at a point, then comfortably you can use the Lami's theorem. So you have the test on Sunday, I think, correct? First session is.
Yes, sir.
So the portions for the first test is right from the beginning. So this equilibrium of planar force system is not included, and also the resultant of non-concurrent forces is not included. So from the beginning, the definition of force and the classification of system of forces and the types of forces, and we have discussed the concept of couple and moment, and also the law of parallelogram of forces and Varignon's theorem we have discussed, and also the problems on the resultant of concurrent force system. The resultant of non-concurrent force system, and this one is not included. Only from right from the beginning, the types of classification of forces, the principle of transferability, the definition of couple, the characteristics of couple, the concept of moment, law of parallelogram of forces, the Varignon's theorem, and we will have problems on the resultant of concurrent force system. We go through that. So in part B, that is, we have completed the centroid chapter. So we'll have derivations, whether it may be a right angle triangle, or semicircle, quarter circle, or sector of a circle, by the method of integration. So you will have one derivation and one problem. So you will have totally 4 questions. So 1 or 2. So each questions you have AB, 1 AB or 2 AB, 3 AB or 4 AB. So any clarification again if you need? So the portions for the first test is in part B, you have centroid, and we have solved a couple of problems on centroid. So we'll have some derivations and the problems on centroid of plane figures and geometric shapes. And in part A, you have one of the derivations, whether it may be law of parallelogram of forces or the Varignon's theorem, and some basic definitions, classification of system of forces, principle of transmissibility. So all those things we have discussed. So anyway, I'll be ending the class. So we shall meet after the first test. So till then, have a nice day. Study well. Hello, any clarification or any doubts, if anyone?
Sir,
Tell me.
so while finding the direction of the resultant, theta value negative we should take or not, sir?
No, you should not take negative. So resultant is always a positive value, no?
Yes, sir, but in exercise problem ಅಲ್ಲಿ ಕೆಲವೊಂದಿಕ್ಕೆ ನೆಗೆಟಿವ್ ಕೊಟ್ಟಿದ್ದಾರೆ.
Only for resolving purpose. Okay. So resultant component ಕೊಟ್ಟಿರ್ತಾರಲ್ಲ. Hello.
Yes, sir.
ಅವಾಗ resolve
Yes, sir.
component ಮಾಡ್ಬೇಕಾದ್ರೆ they might have used. But most of the time, resultant always makes, whether it may be in the first quadrant or second quadrant or third quadrant or fourth quadrant. In first quadrant, both the components are positive, correct?
Yes, sir.
Second quadrant, it may be one is positive and one is negative. If you resolve the resultant, you can take minus sign, no problem. Okay.
Yes, sir.
Huh?
Sir.
Some of the problems you may have these type of things. Otherwise, directly in a concurrent force system, you have to calculate some of the horizontal components, some of the vertical components. You then use that equation, R is equal to square root of sigma f of x square and f of y square. Then find out the angle theta, tan inverse sigma f of y by sigma f. In some of the problems wherein the resultant will be given and it makes an angle with respect to some of the axes. In such a case, we need to resolve the resultant into two components. In such a case, you may use the negative sign. Okay. So anyway,
Yes, sir.
problems will be simple. Concept remains same. So study well. So do it. Okay. Take up the test confidently.
Yes, sir.
So I'll be stopping the session. So I hope you have marked your attendance in the chat box. Okay. All the best.